And we're here with Tony Viana. Hey, Tony. This device looks like the same one that was with the laser trackers. Do I have that right?
Yes, you do. This is the Roma Absolute Arm with the integrated laser scanner.
Now, you look like you're measuring a bike here. That's kind of interesting. Tell me a little bit more about that.
Um, well, elite bike racing today it now has rules to govern the design, the shape and the dimensions of the bike frame. A bit like Formula One car racing or NASCAR or something like that. So it used to be that you could just measure a bike in the days when it was just made with some tubes, and you could do that just with a tape measure and a protractor. If you look at this bike here, you can actually see that the shape is much more complex. It's got a lot more swoop to it, I would say. So what happened is we were contacted by the World Cycling Federation, the UCI, and they asked us to develop a system that would be fast and accurate and above all portable, to allow us to check these bikes for dimensional problems, and to check really that they're conforming to the rules.
So, every bike in every bike competition has to be measured with the scanning arm? That sounds like it's going to take a lot of time.
Well, it's not exactly like that. If you look on that bike frame over there, for example, you'll see a seal from the International Cycling Union. And what that seal means is it means that that bike has already been certified using the Roma Absolute Arm. So what that means is a racing team can go racing with that absolutely serene in the knowledge that the bike meets all of the rules governing the design of the bike frame.
So, meeting the rules means no cheating. Now, there was some talk about cheating with the Tour de France, right?
Yes, there was. That's been in the newspapers quite recently. And in actual fact, we were contacted by the UCI again last year to actually accompany them on some of the stages and check some of the bikes as they were coming in on the finish line. And we were able to sort of bring some results and show the UCI things that they hadn't seen before, and there was evidence of teams trying to gain an advantage.
So, why do they use an arm? Why not use some other technology from hexagon metrology?
Well, like I was saying, really there are a number of factors, but I would say the key one is probably portability. If you think about the Tour de France, that brings with it a whole bunch of logistical difficulties. So you can imagine there aren't many measurement systems around that would allow you to go into the middle of a field in rural France and check, a complex shape to a very high accuracy.
Right, right. I understand. Now, does that mean that this system could be used for other sports as well?
Yes, that's exactly right. So it could be used. It could be used for any sport that uses complex equipment, or rather, equipment that has a complex shape.
So, is this system similar to the Romer arm used in industry?
Yes, yeah, it's actually exactly the same. The only thing that we've changed in this case is the software side of the solution. So the hardware side of it is off the peg. What we've done is we've really isolated the most important commands that would allow you to check a bike from start to finish, and to do that as fast as possible. With the software in its standard configuration, I think to check a bike was taking around 50 minutes. With this kind of reduced interface that you can see here, we can do exactly the same thing in less than 10 minutes.
That's great. That's really interesting. Thanks, Tony.